Okay, let's get started. So I want to start by offering a warm welcome to everyone who's listening to this workshop on the live stream, and the same goes for everyone who will be listening to the recording of this after the event. So my goal for the next hour is to introduce a tool called Shiny. So this is an R package that allows you to simply and easily build web applications without having to know any JavaScript or HTML. So even though this is an R package, it doesn't mean that these web applications are limited to R code. In fact, it's very simple to take your existing Python analyses and Python code and convert them into an interactive web app. So this is really useful for if you want to send your work out to someone who maybe isn't a technical user, who can't set up a Python environment and run your code, but at the same time you don't want to give them just a static file with the output. This is something that Shiny can let you do, and it's very simple to take those existing analyses and convert them into a Shiny app. So let's get started with a few introductions. We'll start with a little bit about me and what my background is. So my name is Tim, and I am an undergraduate statistician. I'm currently taking a year out in industry as a data scientist at AstraZeneca. So there's very much two sides of my work there. As a statistician, I use a lot of R. It's a very statistically focused language. But as a data scientist at AstraZeneca, there's lots of machine learning, lots of simulation. Python is a great language for that. And so I've grown to love both languages for what they're good at. And in the data science community, there can be a bit of a dichotomy between these languages, where there's always the question, which language is better? But I like to think that really they both have their own benefits. And so R is very good at visualization, at creating beautiful plots and animations, and as we'll see today, very good at making interactive web applications. And Python, very fast, good for simulation, good for machine learning and deep learning. And so the goal of this talk is to show how those two skill sets can be brought together to really kind of take advantage of both those languages. So here's the outline for the workshop. We'll do about 5 minutes of introductions, and then we'll move into explaining what exactly Shiny is and building kind of a hello world example of a Shiny application. And this will take about 20 minutes to do and will involve a live coding session. We'll then move on to asking how we can take our Python code and integrate that with Shiny to use Python for the heavy lifting, the heavy computation, and then use Shiny to very simply and easily make a user interface that's interactive and responsive. And then we'll spend a bit of time looking at how we can share our Shiny applications. Once we've made these, what can we do? How can we publish them on the web? And you'll find out it's actually very easy to do that. And then we'll wrap up with a Q&A session, any questions about how Shiny works, what it can do, what it can't do, and also how R and Python are beginning to work much better together. So some prerequisites here. There will be live coding in this workshop, and you are free to join in and try and follow along with the code as I go. I would advise, though, that perhaps it's better just to watch and try and understand what the code is, and then I will release all the presentation material and the final source code on GitHub. There'll be a link on the final slide, so you can download this code, give it a try for yourself, and perhaps extend it if you want to. If you do want to do that, there's a few prerequisites that you'll need. You will need an installation of R and RStudio. So R being the programming language, and RStudio is an IDE, a way like a text editor for the language R. Both of these are very easy to install. You can follow these links, or you can search on Google for their names, and it's as simple as click download, click agree, and it'll install itself. We'll be using two R packages. The Shiny package, which we'll be using for creating these web applications, the interactive web applications, and the Reticulate package, which is used for letting R and Python communicate together in a seamless and efficient way. And both those can be quite easily installed if you Google how to install a package with R. Now, there's two optional extras. The Reticulate package is capable of working with Python virtual environments. It works with virtual env, conda, a few others too. And so if you want to separate all this R Shiny collaboration from your normal Python environment, then this is the way of doing it, and you can set up a Python environment to do that. And lastly, if you want to publish your application and share it with the world, then there's this website called shinyapps.io, which is ran by RStudio, that lets you publish your applications for free, and they'll host it and scale them and manage all the connections for you. So if you want to share with the world, that's the way to do that. Okay, so we'll get on to the first topic, which is how do we build a Shiny application? First, let's answer the question, what is Shiny? So Shiny was developed by RStudio about a decade ago now, but it's come an awfully long way in the meantime and has really grown into a mature platform. And the philosophy behind Shiny is to making an interactive web app as simple as possible, to make them very easy to build and make them flexible and simple. And so if you want to make a Shiny web app, you don't need to understand how HTML works, you don't need to know CSS or JavaScript. That's all handled for you in the background. If you do know these technologies, then that's absolutely wonderful, and Shiny is compatible with them, and you can use them to push your Shiny code even further, but it's not a requirement at all. And so the Shiny framework is extendable and flexible. There are loads of third-party plugins that can allow you to do a lot more than what base Shiny does. There's many integrations with existing JavaScript services. So if you want to use Plotly or Leaflet Plots or D3 in your Shiny applications, you can connect them very simply. You don't need to know any JavaScript. They're already linked together in a seamless way. And you can create some really beautiful and powerful applications with a lot less effort than will be required using JavaScript directly. And Shiny is scalable and production ready. You want to use these in commercial environments, you're welcome to. Multiple connections and resource handling is automatically managed. You don't need to be thinking about all those connections, so it's very useful for that. And really the reason we want to be using Shiny is that if we have some code which we think would be better used by a domain expert, so they can really, people who understand their data and can really glean a lot of information from it, but they might not have technical knowledge, then Shiny is a way of putting the data in their hands without exposing all the R or Python code going on in the background. And so, this makes it very easy to work with domain experts. And in my work at AstraZeneca, I spend a lot of time doing this, developing applications to give to chemists who are not familiar with Python or R, and they don't even have to know that that's what's going on in the background. They just see a very nice interactive web application to mess with the data. And so if you want to learn more about this, if you get access to these slides from the link at the end of the presentation, you can follow this link and it will go to the Shiny tutorial page as an introduction on getting started with Shiny and what Shiny can do. So the key programming paradigm behind Shiny, what really makes Shiny special, is this notion of reactive programming. So I want to consider this example here. We start by setting a equal to 1. We set b to be 1 more than a plus 1, and then we set a equal to 2. Now in a traditional non-reactive programming setting, I hope we'd all agree that if we printed the value of b right now, we would get a value of 2, because the last thing it was set to was a plus 1, and at that time a was equal to 1, and 1 plus 1 is 2. But in a reactive setting, if we were to print b, we would actually get a value of 3. And this is because in reactive programming, when we use this b equals a plus 1, it's not an assignment as it is with traditional programming, but instead it's setting up a relationship between a and b. It's saying that b should be 1 more than whatever a is at the time. And so, as you mentioned, that reactive programming is not a concept that is only used in Shiny. There are reactive programming frameworks for Java, for Python, and many other languages. Shiny just takes this idea and really runs with it and utilizes it to its full extent. And so why might we want reactive programming? What benefits can we get from using it? Well, it's really good at linking together input and output in our application. Say we have some sort of drop-down input that the user can select, and we want to use that to control how a plot displays. In a traditional programming context, we'd have to be monitoring that input and making sure we're aware of when it changes. Then we'd have to read that value, change the plot, make sure we update the output, and we're doing all that, and we're probably having to handle some multi-processing too so that the rest of our application's working. It gets very complicated very quickly. Yet with Shiny, because we're using reactive programming, that output can use that input variable in its definition, and Shiny in the background will handle all that connectivity, all that relationship, because reactive programming is made to handle those relationships. So with that in mind, let's get on to making a simple example with Shiny. And so we're going to use this dataset called the iris dataset, which consists of measurements of the sepal and petal lengths and widths of 3 types of iris flowers. And we're going to create a web application that looks just like this picture here, where we will have an X variable and a Y variable that can be chosen by the user. So if you pass it to a domain expert who knew a lot about iris flowers, they could pick the variables that they cared about and would get a plot corresponding to that. So let's get started. If there are any questions about the code that I'm doing, please do pop them in the chat. I will try my best to pay attention to what's going on. So do feel free to shout up if there's anything concerning you. So we'll start by creating a new R script. Go File, New Script, and at the moment I'm in RStudio, which is an editor for R. I'm going to save this in the Shiny with R folder. I'm going to call it app.r, and this is just the classic name for Shiny applications. You could call it anything, but app.r is the traditional name. So we'll create that there. The first thing we need to do is to load the Shiny library. So we do library and then Shiny. And so this is the same as if we were in Python, we would do import Shiny. It's worth mentioning at this point that we are going to be doing a bit of R coding now, but the important thing is that the only R code we need is the code for building this application. We'll soon see in a second that the majority of your application can be handled by Python. All we're doing with R is kind of gluing together all our bits of Python code to make a user interface and all the logic of the backend. So we start by importing Shiny. And then a Shiny application is made of two parts, a user interface and a server component, which is all the background logic that makes everything tick. So we'll start by creating a UI. So we'll call it UI and we'll assign it the value. In R we use this left arrow for instead of the equal symbol, but you can just imagine that's an equal symbol. And in a similar way that we would if we were making a HTML page, we'll create this application by nesting different sections. So we'll start with a section for the whole page, and inside of that we'll put a title and then a sidebar layout, and inside of that we'll have a sidebar and a main plotting area. So we'll start by using this fluid page function, and this will create a whole page for us. And this is just a function that accepts more UI elements as the arguments. So inside this first argument here, I can put a title panel, and I can give this a name using Shiny with R. And because these are arguments of the function, we just separate them by commas. And now we can also add a sidebar layout. So this is going to let us have, like in this picture on the side, a sidebar on the left and a main body on the right. So we'll take this as just another function, so we can put more UI elements as its arguments. We will put a sidebar panel, which will contain our user interface. We won't add that just yet. And a main panel that will contain the main body of our code. And inside of this, we're going to put an output for that plot to go in. So we use the plot output function for this. And so Shiny has many types of output functions. There are plot outputs, text outputs, HTML outputs, even UI outputs. And these outputs are used for any bit of your UI that's going to be reactive is going to update based on user input. And so here we use a plot output because we want a plot to display when the user changes the variables. We have to give this an ID, which is what we'll refer to it as later, and we'll call this iris plot, say. It's quite a sensible name. And so that's our user interface done for now. So now we can move on to the server. And this is just another function. So this is going to take two inputs. It's going to take a value called input and a value called output. And so these are lists, which are the equivalent of Python dictionaries, just key value pairs. And so the input object is going to represent all of our inputs that we're giving to our application, all the drop-downs, the toggle switches, all of those. And the output will represent all the things we're outputting, all the plots, all the text, all the HTML. And so we pass them into the server function to let us have access to them. So we define a function, and inside of here we put all of our server logic, all the stuff that makes the web application work. But for now, we'll just leave that blank, just so we can see what an empty application looks like. And then to finish off, we can put these together using the Shiny app function. So we'll put in the UI and the server, and this will bind those together to make an application. And if I click save, R will recognize that this is a Shiny application, and I can click run app, and it will run the application. It's quite boring at the moment. We haven't actually put anything in it, but we can see that this will react to the size of our viewing pane. And this is all HTML and CSS and JavaScript all in the background, but we never had to code any of that up. It just made it, which is really quite wonderful. So now we'll get on to adding a plot, and we'll start by making a plot that is not reactive, that doesn't update, and then we'll add that reactivity after. And so to do this, we'll need to use this output variable, and we'll access the iris plot object of that variable. So in the same way in Python we use these square brackets for accessing a dictionary, for accessing a list, which is the same object in R, we use this $ symbol. And so we're going to assign this the value of a renderer function, and specifically a renderer plot. So every output function has a corresponding render function. So the output function is kind of a placeholder for our output to go, and then the render plot is the thing that actually makes the output happen. And importantly, by calling render plot, we let R know that we want to be using a reactive context. We let it know that in this section, so in the section between these curly braces here, everything should use reactive programming. And at the moment, we're not going to have anything updating, so we won't see that. But in a second, when we add the interactivity, it'll make sense why we need to tell R that this is a reactive context. And so what we're going to do, we're going to create a plot of these iris points, of the different iris flowers. So for our x-axis, we will use the sepal length. And we're using these this double square brackets notation. It's similar to the pandas single square brackets, but R uses square brackets for reasons we don't need to go into. And then we'll use the sepal width for the y value. And then we're going to colour this plot by the species of the iris flower. There's 3 species in this data set. We'll add a bit more just to make the plot pretty. We'll use a plotting character 16. That is a dot. And what else are we going to do? We'll add some x labels and y labels. So our x label is going to be sepal.length, and our y label is going to be sepal.width. And I'm also going to add a legend. I'm just going to copy in the code for this because it's really not important for this. And once we're getting onto Python in a second, you'll see that the R is not that important. So now we have this server code that's going to be put into the iris plot output, which will be displayed in the place that we specified for it in the UI. If we reload the application, we get this plot here. But at the moment, the plot doesn't do anything exciting. It's just a static plot. So we haven't achieved anything with Shiny just yet. But in one moment, you'll see that we can very simply take this and make it into an interactive web application. So to do that, we'll go back up to this sidebar panel here. This is the empty sidebar we have on this side. And so let's add some inputs to this. In the same way we had all these output functions, this plot output, the text output, UI output, there are also multiple inputs that Shiny has. So we can use select input to create a drop-down selector. And as with the output, we'll need to give this an ID. We'll call this x_var. It's going to represent our x variable. And we can give it a bit more information too. We'll give it a label, which is what the user will see written above it. We'll call that x variable. And then we'll need to give what choices are available for the user to choose from. And we're going to use a bit of code here. The exact code doesn't matter. All it's saying is that we're going to take the column names of the iris dataset and get rid of the column species, because we're already using species for the colour, so we don't want that to be one of our x or y variables. We'll take this input and we'll copy it, separate by commas. These are just arguments to the sidebar panel function. And we'll create a y input using this as well. The exact same choices. And actually we'll set the initial value of this value to be sepal.length. So by default, if we don't specify an initial value, width we'll use, it will just use the first column name. But it would be quite a boring plot if we had it being sepal length against sepal length, so we'll just specify we'll use sepal width for the y input to start it off. So once we have those, our input variable that we pass into this server function is now aware of those inputs. So we can simply replace the reference to the sepal length column with the value of that input. We access that with that $sign again. So we called that xvar, so we'll access that there. And we call this one yvar, and then we'll also change these labels here as well. So we'll take the input, we don't need the quotes because these are variables, the x variable, and the y variable too. Okay, and if we were to run this now, didn't like value. I think this should have been selected. Yeah, my mistake. There we go, we get the output here. And now if we update these inputs here, the plot automatically changes. You can see that's instantaneous. And we've had to do nothing to make that update, it just automatically did. And the reason for that is that because we put all this code in the render plot function, R was aware that this is a reactive programming context. And so it looks at these inputs and it goes, well, this output is dependent on these inputs. and therefore whenever I update these inputs, I should automatically update the output. We didn't have to specify that, R just did it, which I think is absolutely amazing. When you compare that to the way you might have to do that in a different language, it really is that simple. And you get these instant updates, you can change both of them. Those are exactly the same. And the beauty of this is that if you gave this to a domain expert, someone who knew a lot about iris flowers, obviously this isn't a very complicated example, but imagine for a second it was, they could go, oh, from my experience, I think petal width and petal length should be correlated. So they could get that data for themselves. They don't have to look at any code. They don't even have to know what's going on in the background here. It just works for them very seamlessly. So that's the end of that demo. We'll move back to the presentation now. So you can see we just made an application that looks just like that. And how many lines of code was that? Yeah, less than 50 lines of code. You could probably use even less if you wanted to get rid of some of these spacings that you add for clarity. So really about 40 lines of code to achieve so much. It really is quite impressive. So now what I'm sure quite a few people have been waiting for, how do we get Python involved with this? Because I appreciate that not many people use R. And so rather than this whole talk being about how we can use R in Shiny, I want to focus now on how we can use Python code to do all the computation and use R literally just to make that UI and set up that reactive programming. And so we can do this using this notion of reticulated Python. So Reticulate is a package that was developed by RStudio quite recently, but it's already quite mature and stable. And it enables interoperability between R and Python. So basically lets them talk together and run very seamlessly together. So what it lets you do is you can run Python within an R session and let the two languages talk between each other. And it facilitates translation between objects in both languages. We'll get to more on that in the next slide. And it also offers very flexible bindings for using Python virtual environments. So if you use virtual env or conda, then Reticulate can connect up to them, use that version of Python and those packages, and it works seamlessly. It's almost as if you are in a Python editor using your Python. If you want to learn more about this, you can follow this link, and that will go to the introductory page on the RStudio website about reticulated Python. So more on this object translation. How is it done? So it's using these C++ APIs, so they're lightning fast. You barely notice any slowdown in your code unless you're translating, absolutely gigantic data frames. There is a bit more memory usage, but it's not really anything that noticeable unless you're looking for it. And the important thing is that all object types that we care about in R and Python have natural equivalents, and so you don't need to be worried about translating from one to the other and getting it back in different shape, like you might with like a actual human language. With these programming languages, things translate very naturally. And so if we had a named list in R, that translates almost perfectly with a dictionary object in Python. So we can go forwards and backwards between these two seamlessly. Matrices in R have NumPy arrays in Python, data frames and pandas data frames. And that's because R and Python have quite similar backgrounds in where they came from and have inspired each other a lot. So anything that really matters in R and Python can be translated very easily. So we'll now move on to a live coding example of how we can use Python. I thought the best way to showcase the power of Python for Shiny was to focus on an example that used simulation. Because R, as much as I love it, it is a slow language, and in some cases it can be about 10 times as slow as Python. And so we can leverage Python for doing this simulation very quickly, and then pass it back to R to build this interface, which is something that Python would find maybe a bit harder to do. There's less mature tools for that. And so we're going to focus this around this thing known as the central limit theorem, which is it's a bit of a complicated statistical topic, but essentially all it says is that if I have a bunch of coins and I flip them all and count how many heads I obtain, if I was to repeat that experiment multiple times, then as the number of coins I toss in each experiment grows large, the distribution of the number of heads should be roughly normal, that classic bell-shaped distribution that we see for the height of populations. And so we'll create an application that will demonstrate this and look something like this. So we'll go back into RStudio. I'm just going to close that previous application that we had, and we'll create a new R script. And I'll save this in a different folder, calling it app.r again, that traditional name. And so we'll start by building the user interface, and then we'll move into Python to do all kind of the hard simulation work. So as before, we start by importing the Shiny library that gives us all those Shiny functions. and then we create our UI. So we'll start with a fluid page. That's the whole body of our web application. We'll add a title panel with the title using Shiny with Python now. Another element of that, we'll add a sidebar layout. And inside of that, we will have a sidebar panel. This bit that's going to contain all of our UI. And then we'll also add a main panel, which will contain our output. So we're going to want another plot output like we did in the last example. So I'll just put that in there, plot output, and we'll give this the name, should we say heads plot, because it's going to have the distribution of the heads. Okay, so that's our UI created. We can go on to the server code. So as before, this is a function accepting inputs and outputs. Put all the code between these curly brackets. And then we're going to assign a plot to this heads plot output. We'll use the render plot function for that. It's the corresponding renderer for a plot output. That lets R know that we're in a reactive context here. And then we can fill this with, so we won't use Python just yet. For now, we'll cheat a bit and assume that the central limit theorem is true and that our simulated data will in fact be normally distributed. We'll just create 100 random normal variables. We're going to cheat for now, but we'll use Python to simulate it properly in a second. And then we can plot this using a histogram. Actually, let's have 1,000 of these. That might look a bit better. We'll plot those simulations. I'm just going to copy across some formatting code, just because I can't remember color codes off my head. There you go, so that'll make it nice and pretty. And we'll add the X label will be number of heads. Okay, and then we can tie these two things together by running Shiny app with the UI and the server. So once we click save, our registers this is a Shiny application. We can click run, and we get this histogram here containing, well, it doesn't really contain anything of interest because we didn't actually simulate any data. But we can see that the application is working. So now, how can we get Python involved with this? Well, first let's create some inputs. We'll put these into the sidebar panel. So we'll start, as we can see on the side here, we'll use a numeric input. And this will let us input a number. Also has a little up and down arrows on the side to increase numeric input, to increase or decrease the value. We'll give it an ID. We'll use the ID num tosses. This will represent how many tosses we do in each experiment. And we'll give it a label for the human to read. And so we'll use the label number of tosses, number of coin tosses, say. And then we'll give it an initial value of 50 is a reasonable value. And then we'll add another input, another numeric input. We'll call this one num sims, which will represent the number of simulations we do, the number of experiments we do. Give this a label of number of simulations. An initial value of 1,000. So I think you'll see, like, because we're using Python, we could easily push this way past 1,000 because Python's quite good at handling that sort of simulation. And then we'll also add a slider input. And just to make things a bit more exciting, rather than using an unbiased coin, like a fair 50-50 coin, we'll allow for a bit of bias in the coin. So we'll have this input, which we have the ID bias for. And the label for this is going to be probability. I should know this word as a statistician, of obtaining heads. And we'll need to give a bit of information about it. The initial value is going to be 0.5. The minimum value is going to be 0. The maximum will be 1. And will increase in step sizes of 0.1. So if we have a look at this now, see we have these inputs. They don't do anything at the moment, but they exist. And it just take a second to, remember how difficult it would be to set up this sort of form using JavaScript or HTML. Whereas here we just literally specified what it's called, what the value is, min-max step, and we have this beautiful input here. And we can connect it to our application in a very simple way. And so we can now go down to our simulation section and replace this with an actual simulation function. And we'll call this function headdist for head distribution. And we're going to pass in the input of the number of tosses, the number of simulations, and the bias. But we're not going to define this function in R. We're going to define it in Python. So we can now go File, New File, and Python script. And actually, you'll see here that even though RStudio is an editor for R primarily, it's capable of editing Python, SQL, Stan, C++. It really is a versatile editor. You'll get code completion and syntax highlighting, so it really is kind of a friendly place to be doing Python development. And so now we have this Python script. I'm going to call it simulate.py. And we're going to create two functions. Well, so first, actually, we're going to import the random function from the random module. And because if we're simulating coin tosses, it'd be helpful to have some sense of randomness. And then we're going to create two functions. The first one's going to be headDist, which is the function that we called from R here. And that's going to have the number of tosses, the number of simulations, and the bias. And we'll just leave that blank for now. We'll fill it in a second. And we're also going to have this function, which is going to be called numHeads. And this is going to take the number of tosses we do and the bias. And so this function is going to return, so the numHeads function will run one experiment and return how many heads were obtained in that experiment. And then the heads distribution function will run that numHeads function multiple times, num simulation time in fact, and return the distribution of the number of heads. So we'll start with this numHeads function. We'll create a list where one, so we'll start with creating a list where one represents a heads. So we can do that by asking when it is a random number less than our bias. And so that means if our bias is very big, so our bias is like 0.9, and a random gives a random number between 0 and 1, it's much more likely for this to be true, which is represented as a 1 in Python. So we can use this to represent a head being tossed, and we will repeat this a number of times equal to the number of tosses. Let's put this onto a new line, just for clarity. And then what we're going to do then is sum all of these up. Because a true represents a 1, and so when we add all these up, it will count to how many heads we obtained. But really, the Python code here is not the important bit. We'll be focusing on Shiny. So don't worry if you didn't quite understand what was going on there. And then for the heads distribution function, we can call this numHeads function multiple times. We'll run it with the number of tosses and the bias. And then we will repeat this a number of times equal to the number of sims that we want to do. And this will create a list containing how many heads we obtained on each experiment. So a quick look over, make sure that's all right. Yeah, that's looking good, although I might regret saying that. So now that we have that, this headsDist function in Python doesn't exist in R just yet. You'll see it's very easy to make it exist. So we'll have to add one more package, the reticulate package, and that's the package that is used for letting R and Python communicate together. I spelled that wrong, reticulate. And then we'll have to add one more line, and that's going to be the source Python function. All this does, it accepts the path to a Python file, in this case simulate.py, and then when we run this, it will add all the functions it finds in this file to our R environment, and we'll be able to call them as if they are functions that exist in R natively. So hopefully, fingers crossed, when we... Oh wait, no. Yeah, that's fine, yeah. When we run this, we should get an updating plot. There we go. And actually, yeah, no, that's fine as it is now. And so we can change the number of coin tosses, say we do 500 of them. Actually, you'll see as we increase this, we get a much more normally distributed distribution. We can take this number quite big, so we're doing 10,000 simulations here. It'll take a second to figure them out, but it's pretty quick. Like, so we did, 5,000 tosses times 10,000 simulations here. It's an awful lot of simulations, and yet it just updates, quite seamlessly. It's down to something a bit more manageable, almost an instantaneous upgrade there. Update. And so this is a really good example of using Shiny and R together, because we're using both languages for what they're good at. Building this user interface in Shiny was very simple, like connecting those inputs to this Python function. It was as simple as using them as if they were a variable, and then R in the background handles all that updating because it knows we want reactive programming, and we get to use Python for that fast simulation that R isn't the best at. And even though our Python script here was quite a small one, there's no limit on what we could have put in there. There's examples that I'm using at work where the Python script I'm calling is about 5,000 lines of code, and R and Shiny just handle it with ease. You can use you could call a package. You can call Python scripts that use matplotlib or pandas or numpy. There really is no limit. And also, if you want to generate your plots with Python, if you're not a fan of the R notation for creating plots, you're welcome to do that as well. You can quite easily pass a plot from Python back into Shiny for it to be outputted. So really, all Shiny is doing here, and all R is doing, is creating that input and talking how things get connected. So people are asking about, oh yeah, that's fine, someone's answered that in the chat. So also, it's worth mentioning that even though this is quite a small example, when we scale things up, we don't have to manage all this in one file. That Shiny has a system of handling modules. So we can modularize our code into different files that all work together. And so, as you will with a real website, you aren't forced to be developing in just one file. You can split things up. So if you want to build really complicated things, then you're welcome to. And also, if you want to integrate these things with JavaScript libraries, it's very easy to do so. You don't need to know any JavaScript. You can just install packages that connect Shiny with these JavaScript libraries, and you can get some really amazing things. And we might have a chance to have a look at a list of some of the amazing things that Shiny can do later in this talk. So hopefully people can now see the benefit of using Shiny for your existing Python applications, and are maybe considering whether their next project they might want to give Shiny a go. So we'll move back to the presentation now and ask, how can we share our content once we've developed an application? And so there are a few ways that we can publish a Shiny app. The easiest to use is this website called shinyapps.io, and this is hosted by RStudio, and it lets you publish Shiny apps for free in a very simple way. You're limited to only 5 apps per account and 25 active hours a month. This is actually quite a bit if you're just developing things to mess around with, but you can upgrade for, it's not too expensive, if you want to have more applications and more active hours. But as a free plan, it's really quite a good deal because they handle all the connections for you, all the it just works. You upload it and it works exactly the same as it did in that viewer there. You're given a web link to go to. You can have a look. I can actually show you what the process of uploading looks like. So we had this application here. I click publish, and I choose which files I want to include. So it was the app.r and the simulate.py. I click my account from the right, or I create an account, and then I just click publish, and it's as simple as that. And so once that had been uploaded to their servers, you would then be given a web link. You could visit that, and it would just work. You could have multiple people connecting to it. All the scalability is handled by Shiny and by RStudio. It's very simple. Going back to that, there are other options. So if you already own your own server, or you're hosting a server on, say, Amazon Web Services, GCP, DigitalOcean, any of those providers, then it's very easy to set up this open source application called Shiny Server, and that lets you run your own version of shinyapps.io. So it's very simple to set up. Just install a few files, forward a few ports, and it's all set up. And then you can publish applications to your Shiny server in the same way that you did with that publish button there. You just click your server rather than a shinyapps.io account. And so, yeah, if you have one of those things set up already, it's very easy to move your applications to a server like that. If people are interested in using this in a commercial setting, then that's completely possible. There's this software that RStudio offer called Shiny Server Pro, which basically takes Shiny Server and adds some enterprise features to it. So that's for managing even more connections, even more users. There's more permissions management and secure access. You can have advanced management of your connections and your resource usage, try and manage how your server is being used. And it also has many professional data integrations, so you can connect to Spark databases, to Amazon Web Services data stores, many things like that. So yeah, Shiny is not just something that you can use for your personal development. It's used in many large companies to really strong effect. And so I want to have a quick look at the Shiny showcase. We mentioned about sharing applications here. I thought it'd be good to have a look at some of the things that other people have shared. So there's this website called Shiny Gallery. You can find it on this link, or if you Google Shiny Gallery, you'll be able to find that. And it shows many examples of what Shiny can do. So the examples we've looked at today are very simple, and I don't think they'll really impress anyone. But if you want to see the real scope of what Shiny can handle, this is a great place to look. Just have a browse through what's available. I wanted to have a particular look at this example of a Shiny application that's used to solve the traveling salesman problem. So we'll just open this up, drag across here. So it might take a second to load up because I'm already using a bit of internet connection here. But the traveling salesman problem is a notoriously difficult problem, and it involves you have a list of different cities and the distances between them, and you want to find the shortest route that traverses all of those cities. And so this can be handled in Shiny in an interactive way, and it's pretty damn fast. So we take these list of cities here, so quite a few of them, and it starts with a random route between them. You can click the solve button. It's not an analytic solver. It uses an approximation to solve it, but it's most likely the correct solution. You click solve, it'll try a few optimizations, and then it'll come to the conclusion that it's struggling a bit, but there you go, yeah. So it's decided that this is most likely the optimal layout. So if you navigate through these, this is the shortest way of connecting all of those cities together. And so the background of this is it's running R. It's quite a massive script. I downloaded the source code for this, really quite complicated. But if you want to connect this to Python, then you'd be completely able to. And it might actually even run quite a bit faster. And as a user of this, I don't have to be aware at all that what's going on in the background is R or Python. It just works for me. And it also has the advantage that because all of the computation is happening on the server, rather than if we use JavaScript, it would be occurring on my browser most likely, you can leverage the power of a server to have this kind of quite complicated optimization process happening, even if my computer isn't the fastest. All I get is the input and the output, and all that middle bit's handled by R or Python if that's what you want to use. So moving back to the presentation now, a few closing remarks. So a quick summary of what we've covered in this workshop. So we've obviously talked about Shiny, and so Shiny is a very powerful tool, very flexible, very easy to use. You only have to learn a few commands before you're able to use it effectively. And a lot of things we learned today, like this plot output, once you know how to use plot output, well then text output, HTML output, UI output, they're all the same idea. And so once you picked up those few basic ideas of here's my inputs, here's my outputs, here's how reactive programming works, it's quite simple to build complicated applications using those ideas. And I add this mention and more here because actually Shiny is not just used for making web apps. That's its primary use and what it's kind of infamous for. But Shiny can actually be embedded in a lot more applications. So for example, Shiny can be used in data science reporting. So if you're making some sort of PDF report and sending that out to somebody, well, if you're sending out a static PDF, you might have this to and fro where you send it across to them, they go, oh, that's good, but could you add this data? Or could you swap these axes around? Could you color this in this way? Could I see these two variables compared? And you go forwards and backwards, wasting everyone's time. Whereas if instead you send across a Shiny-enabled report that was interactive, you could add buttons and toggles into your report, and so someone could say, well, I want to compare these variables, or I care about these correlations, or I want to color my chart with these by this variable. They can do that. You don't have to do anything extra to make that happen. It just works. And another example is Shiny can be used to build interactive presentations. So similar to PowerPoint presentations or your JavaScript presentations, but the content can be updated on the fly. So an example that I often use this for is when I'm working at AstraZeneca, a lot of people who are statistically or mathematically trained like their logarithms to be the natural log, whereas all the chemists and engineers like their logarithms to be base 10 logs. And when I'm going into a meeting, I don't know which one will be preferred in that meeting, because I don't know who's going to be there in advance. And so I guess I could make two presentations, each with a different version of logs, but that's a lot of fuss. So instead, I use Shiny to make these interactive presentations. I just have a toggle switch on one of the slides saying, are we using base 10 or natural logarithms? And then all my plots automatically update. And it's just really handy for making these simple presentations that are flexible and adapt to the audience. And so RStudio is devoted to making bilingual data science simple and efficient. So it used to be the case that R and Python were basically not competing, but weren't exactly being friendly with each other, weren't trying to make it easy for each other. And then I think RStudio decided as a company, no, we need to bridge that gap because each of the languages have their own benefits. And so RStudio has been trying very hard over the past 5 years to really make working between R and Python as simple as possible. So one example of this is the reticulate package, which makes communicating between R and Python very simple to do, very efficient. There's also a lot more. So RStudio is now compatible with Jupyter Notebooks and Jupyter Lab. And so you can take your existing Python notebooks and use them in RStudio. Very simple. And there was a blog post posted by RStudio only a few days ago now, showcasing that they now have integration for both Flask and Plotly Dash in RStudio. So if you did want to build a Flask application, but have R and Python playing together with that, you can. You're welcome to. I'm sure over the next few years, there'll be much more that RStudio will expand the scope of this to the point where there isn't really this language wars anymore. It's R and Python, are almost like they're all that data science toolkit, and for whatever job you're working on, you pick the one that's most relevant to you. And so we also talk about the reticulate package, which offers a way of combining R and Python together. We saw this in the context of Shiny, but reticulate actually lets you use R and Python just completely together in any context. So R has this thing called notebooks, which are equivalent to Jupyter notebooks. And something that's always frustrated me about Jupyter, that if I want a notebook that has both R and Python in it, it's very difficult to set that up. Base Jupyter doesn't allow it, and there are special kernels you can install to let you do that, but they're a bit of a faff and they don't really handle the translation too well. Whereas R notebooks lets you use R and Python in the same notebook. So I can have one cell that is in R, I can then put my next cell in Python and use that variable defined in R as if it existed in Python, and vice versa as well. I can use my Python variables as if they're in R. So I can do my analysis using pandas and then make a plot using ggplot, go back to Python and do some machine learning, and just seamlessly transition between those two things. So a lot of work has been put into that, and it really is quite amazing what's going on there. And so a bit of further reading if you've been interested by this topic. RStudio have a blog post called R and Python, a Love Story. It's actually more than just a blog post. There's a webinar based on this and some resources linked from that page. And it basically documents their journey in kind of making R and Python work well together, bridging that gap between the languages. There's this website called Awesome Shiny, which is just a GitHub repository listing everything awesome that Shiny can do. It's definitely worth checking out because base Shiny itself is very powerful, but it has its limitations. But because Shiny is such a flexible framework, many people have gone and developed add-ons and extensions for Shiny that can do some absolutely crazy things. So one example that I've been using in my work is there's this JavaScript library called VisNetwork for creating complicated visualizations of networks and graphs. And they have physics, and you can delete nodes and add nodes and zoom in and zoom out. Really clever stuff. And that can be linked to Shiny without having to know any JavaScript. You're just given an interface to that in R, some very simple functions, and you get to play around with that, connecting that all up to your reactive programming so your graph can update very simply based on user inputs. So really some amazing stuff. Please do check that out. And finally, there's a link to, on RStudio's website, there's these Shiny articles, which are basically both tutorials on Shiny and kind of demonstrations of what Shiny can do. So some examples of the things that we haven't mentioned is that Shiny has bookmarking abilities, so it can save the state of a current application and give that to you as a bookmark with a little bit of code at the end of the bookmark URL, which will then restore the state. So if you went to that link again, you'd have the exact same web application open. And so there's loads of things that Shiny can do. You can have authentication of who's accessing the web application. You can link it with databases. There really is kind of no end to what you can do. I'm always amazed with some of the amazing things that Shiny offers. And so that brings us to the end of this presentation. I want to thank you for attending. I really hope you've learned something or been inspired to give Shiny some consideration when you're next working on your Python or R projects. All the presentation material and the final code can be found on the GitHub repository for this talk, so github.com/thargreaves #quarantine-talk. And I'll leave this slide up for a few minutes if you want to just visit that and bookmark it if you're interested in having a look at this later. If you're interested in more of my work, you can find all my blogging about data science, about data ethics, algorithms, statistics, and everything related at ttested.com. And now I will open up to any questions. I'll keep an eye on the chat if anyone has any questions about what Shiny can do or how R and Python are playing together, then I'd be happy to answer. So if we don't have any questions, then I might show some examples of what the Shiny extensions can do on this awesome Shiny list. I'll keep an eye on the chat though, so if people do think of questions, then I'll be happy to listen and respond to them. So I'll open up Shiny Awesome here. So just a GitHub repository with I mean, like, just look at this list. It's almost an endless list of what you can do with Shiny. So what are some examples here? So theming. So the existing Shiny framework is not the prettiest. It's based around Bootstrap, but it's not exactly gorgeous. There are many extensions that allow you to add theming to Shiny and make really gorgeous dashboards that look completely professional. You couldn't tell them apart from some actually, getting some professional web developers to make a HTML, CSS, JavaScript web application. And they're very easy to connect up to existing Shiny applications, and works very nicely. In terms of input, Shiny is already capable of handling input and output of files, so you can upload files and have them read in. So I'm currently working on a project at the moment where I'm taking Excel spreadsheets and trying to upload them to a database and make a very friendly to use uploader for that. I guess the other option would be kind of just emailing it to me and I run it through a script, or you just drop it on some web server and it handles it in the background. But using Shiny, it's very easy to make an interface that's friendly and can go, oh, here's your data. I think this cell here is wrong, or it's invalid, and really point that out to the user in a friendly way. And Shiny makes that very simple. And you can also set up Shiny to download files, which is very useful. In terms of actual extensions, hopefully there's a list of some extensions down here. Yes, in terms of visualization. So Shiny, typically you would use ggplot, which is the main R plotting library, but you're free to use many different plotting tools. So Plotly is probably the most popular interactive plotting tool, visualization tool in the Python community, and so you can integrate that with R very easily. And actually, it's more than just using R to make those plots. You can have R and Plotly talk together. So one feature of Plotly is you can use these lasso selectors to, if you have a scatter plot, to select a range of points, and then you can actually pass that really simply back to R, so R is aware of what points are selected, and then you could change other outputs or change your inputs depending on what points are selected. So really are some powerful stuff there. You can use high charter. I think Leaflet will be down here somewhere. There's many different D3 applications you can use, time series applications, tree plots, and networks. There really is a lot that Shiny can do. So please do take a look at this list and see if there's anything in it that does inspire you and you think, well, maybe this Shiny thing is worth learning. So with that, I'll probably end the stream there. But thank you for listening, and I really hope you've learned something useful from it. Thank you.